All right. Let me just read this thing that I wrote. So, welcome to Malmo.js first remote streamed event.
Yoo-hoo!
Before we really start, we'd like to
Yay.
announce that Malmo.js has got a new sponsor, Relax Gaming. So, big thanks for sponsoring our meetups fee. Thank you.
Wow, you're really bringing it. It's your company.
I know. The first speak will be held by Elke Bosman and will be about CrankJS. The second talk will be held by David Waller and will focus on CycleJS. The third talk will be held by me and will be about Svelte. All right. Will you take it away, Elke?
Yes, I will. All right.
You want me to share your screen?
Yep.
So I don't have to share it then.
Yeah, 1 second.
I can't hear him.
You see it?
I think so. I'm gonna make it so that you're the only one who is seen. Do you want to be seen? We just heard.
You can just put me on. Like I like to see myself. It's nice. It's reassuring that people are still listening.
All right, let's do so.
All right, cool.
Good luck.
All right, cheers. So CrankJS. Let's get started. So CrankJS, if you go to crankjs.org, that's the website. You see it's not very pretty. It actually got prettier. You kind of like toned down on the harsh contrast, and it was even uglier than this. But anyway, it's like it's very much a response to React hooks. And I've been vocal a little bit about that I don't like React hooks, and we don't have to go into why I don't like them. But I thought this was pretty interesting because CrankJS is all about kind of like an alternative API for doing state management while still very much looking like it is React. So what is CrankJS? Well, you kind of like have to just like start at the beginning, and then and it's funny. I thought it was much more popular. It's not really old. It's like a month old, but still like 500 downloads a week. Like I think it's just me and the dude who wrote it that's currently using it. I don't know. It's like I just looked through the commit log to see what's happening, and I found this commit, and I just thought it was so funny. Also because I hate bundlers as well, so I feel like connected. So anyway, when you like start out with like just like trying out things, like if you just write a stateless functional component, just like mapping props to elements, it's exactly the same as React. Like there's zero difference. This is kind of nice. Like so you can reuse your skills, your knowledge there. You can also see here that like there's a separation between crank and crank DOM, and also that comes from React. It's just based on the same philosophy. And then like pretty like quickly you immediately have this thing that you don't have in React, because in React function are supposed to be pure, but Crank offers you this async function, and sometimes you just have a component, and like as soon as it like kind of like mounts, you just want to fetch data and show this data. And in Crank you have asynchronous functions that do exactly this, and I really like this function. Like I can read it, and I can get it. Like I almost need no JavaScript experience to understand what this thing is doing. You can just like read it and understand it. And I really like it. Might not like be like that it covers all use cases, but there are definitely use cases where this is actually just does it for you what you need to do. So you can just await in your component, and just like when you have the data, you just render it up. But like the meat of CrankJS is really where it comes to like state management. And this is also like how kind of like this library came about. The author, he figured, well, wait, can't I just do generators instead of like React hooks, and then he started trying out, and he realized, oh, this actually works, and then it became Crank. And yeah, so there's like generated syntax and semantics, and I'm really not like used to that stuff. Like I've written one asynchronous generator in my life, and it was actually really useful in that use case, but other than that, not really like work with it. And after that, kind of like struggled to find use cases for them. So my knowledge of like syntax and semantics is pretty horrible with generators. I kind of like never need them and never used them. And in this case, I just had to learn that. And yeah, you kind of end up with like this like Dr. Axel Rauschmeier, or however you say his name. He has like a duality guy. He always has the best stuff. So there you can get to learn all about generators. And then when you're done, you can like put it on your resume. Really nice. So you know generators. So, just a slight introduction to generators. Basically, as the doctor says, generators are functions that can be paused and resumed, which is really interesting. With a normal function, you put in, you call it, and it just runs until it returns. Like there's no, pausing and resuming. But that's actually what a generator allows you to do. So as soon as you like call a generator, so that would be like here, it actually doesn't like start executing this function. It just returns a generator object, and this generator object is actually implementing the iterable interface. So therefore, it can be looped over here. But what happens inside this generator is that every time it says yield, that value will actually be like the function will be paused here, and this value will be returned. So in this case, letter, will first be A, and then on the next iteration it will B. So that's kind of how like a generator works in like very like superficial terms. You can then also start playing with state, because like you can keep things in scope, and you can start changing that scope, and you can decide to yield different things based on what happened earlier. So if you would have like an iterable that that like returns the next item in the array the whole time, the state is actually the index. But it doesn't have to be just an index. You can like keep any kind of state. And there's this other thing with generators. It actually can also receive values from like the place where the data is consumed. So you can actually put stuff into the generator again, and based on that, you can like change your internal state or make the decisions to like yield different things. So yeah, generators are like really stateful. Sounds like a great match with state management. So this is like back to like Crank. This is like an example of a slightly more complicated component. And now you see like the star here. That's what indicates that it's a generator function. And whenever you have a generator function component or generator component in CrankJS, you always get initial props, just like in React. And you can just like, you can decide to keep it around. And then if you want like the next props, it is simply it's possible to just get this from this. Remember this? It's it's the context, it's the function context. And in the case what Crank does, the function context for this particular component is actually something that Crank owns, but it makes it available to this component. And therefore, every time there's new props, we'll have a new this for loop kind of runs this block, and that means that like, okay, so this block runs, and that means that we can we get the new props, new message, and we can decide if it's the same message, and if it's the same, we render it out like that, and then we yield that. And then by the time this function will continue, the next time that like there is a what do you call it? The next time there's a new props, and therefore the previous message gets set. So you can actually just like I said earlier, you can use the scope, and you can do things like compare to your like previous props, or like you can have like compare to initial props. So it's almost like we have like access to all this stuff that is just coming out of the way that like generators work. Like it's almost API-less up until this moment. And you can also do for example, capture like clicks. So in this case, there's a button, there's an on-click handler, and then when you click the handle click, it essentially like increases the count. And here is actually this refresh is the first time that we really can say, okay, but this is really like some sort of imperative API. Like this is not something that just comes with generators. This is required because we need to tell Crank here, like, okay, so please yield the next iterate to the next value. So call the next on this component, and that basically makes what happens is that this thing yields here, and therefore like we now have we render out this, and we have a new handle click handler, and therefore like it will be bound again, and it's all happening in the same context. So you don't like you don't have this concept of like still props or anything here. It's like this literally works like what you see is what you work. You don't have to like time travel with your mind in order to kind of grasp it. Another cool thing about generators is that you can call not only the next method on them, but you can also call the return method on them. That's what Crank does when a component, in this case the timer component, when it gets removed from the tree. And in this case, we have this timer, and it like has an interval. And when this interval, it increases the seconds, and then it says this refresh, and then this thing will run once, and it will render out, return the updated elements. But when it's done, you actually need to clear this interval, because otherwise this keeps running, and then you get like this kind of like errors that a similar error, I guess, what you would have in React is like you cannot update state after a component has like unmounted. So we need to clean it up, and we can do this with finally. It just comes out of the box with generators. Whenever you a generator, like whenever you put it in the try catch finally block, the finally will run when you execute the return method on them. Pretty nice. And here it gets kind of really. This when I start seeing this, I was like, wow, this is getting really cool. So remember that you from this you get like the new props. In this case, whenever time there's a new ID prop passed in, yeah, we want to like fetch it. And what happens next is that because this is a promise, it starts fetching it, and then when it's done, it yields this new value. So what happens when a new props is passed in? It will flash fetching quote with this ID. Then like it starts doing stuff in the background, but it's still showing this text, and then it actually shows the quote. It's like when I look at this, I'm like, this is so easy. Like, why is not React like this? So this was really, yeah. I think it's fun, very simple and elegant. So this slide he put on his blog. You can read it on their website. He kind of, this is pseudocode. This is not actually how it works. But you could do like this. So like you see that there's all this like React API lifecycle hooks that you could see where they would run. So like the first thing that will happen is component will mount. And what's very interesting here is that you see like you can get any kind of like error component catch, but you can also do like the component will unmount, as we saw in the previous slide. But you even can get a ref, because when you yield an element, you actually get the ref back. Pretty cool. So I made a small demo, and I'm just gonna like show you what it does, and I will like give you some examples of the code, and then I'll wrap it up. So here is the code. So you basically have all these counters on the left, and then you can click one, and then it will fetch it. You click another one. You can also click I'm feeling lucky, and then you get a different country. And sometimes those countries don't actually have statistics, but this one does. And then there's this button, and then you can just go back in time, and it will like update the statistics. Pretty simple stuff. All right, so I want to show this. Hope you can see this. So this is the I'm feeling lucky button. And it gets like an on select, because what I want to happen is that whenever you do an I'm feeling lucky and you actually select a country that is like that, it also updates the this list here. So I lifted up the state like you do in React. So whenever the country changes, I need to inform this this state that's lifted up. So that's what this does essentially. And then whenever you click the button here, so there's a button here, but I'm feeling lucky. After we've told it that there's a new country selected, we also do this.refresh, which makes sure that like we consume the next value from this iterable this context. And this is just essentially, and when that happens, we say, okay, give me from countries here is actually a generated object, because a random country generator here actually returns is a generator. So you see that on the with the star rotation. And so that means that like whenever we do countries.next, we can we get the value, in this case the country, and we get it done. And when it's done, that means that there's no more countries in this case. So in that case, we say, out of luck, no more countries. And otherwise, we're just, again, create a component, return an element, a button, and then with a, a binding, sorry, not a binding, but a closure here created in order to run the on-click with the right country. So I thought that was like pretty simple. There's this other cool thing that once you start thinking, I really started thinking, okay, can I like use now generators everywhere? Because it seems like, okay, so you're generating in your components. Maybe you can also use it for your API layer. And I didn't really have time to really go into it, but I thought like, I noticed that like there's this yield star, and yield star is actually syntactic sugar for this. So you get back an array of countries, and what you could do is you could loop over those arrays and then yield, right? So and then like every time, if you would like loop over this generator over the iterable, then you would each time get like one country. If you would just say yield countries, you would just get one item, which is the entire array. And yield star is essentially just syntactic sugar for that. I thought that was pretty cool. So then there is this other thing that I thought was pretty neat. There is like a suspense, which is like we still don't have it in React, or we do, but like I don't know, it's not officially supported. But anyway, I guess it's officially supported. But you can see how it's implemented here. Essentially, we have this. I guess it's like pretty complicated when you look at it. But anyway, it renders this like a fallback, which is in our case, we actually pass a loading indicator as an argument here. So in our case, it's the loader indicator, and this we yield this immediately, but afterwards we also yield immediately like the actual content. But because both of these are actually asynchronous function, they return like promises. And there's this rule in like in the crank that like it kind of like races it out. So whatever comes last, but like if something that's yielded last isn't like rendered out yet, it will just use whatever came before. So if I go back to the example, you kind of like don't see it. But if I would like make my network slow, so I made this really slow here, and I would like click here, it says fetching, and then is that still fetching, and then I went that like this. And I think this happens. Okay, interesting. The code didn't reload. I don't know why it's broken now. Oh yeah, because it's really slow. Right, there we go. So we're gonna make it really slow, and there we go. Fetching. I don't understand why it does this, but you can make it even slower, and you can have like these different fallbacks. It should reload now. Yeah, there it goes. Oh, it's really slow. Like online. Really slow. You click here. It's fetching. All right. So that was like a slight small demo. Let's get back to the presentation. Just have some like conclusions. I don't want to keep it too long. Essentially, when you start out with this stuff, it's I got I got really stuck. Like I had to call David. So it was it's a generator syntax, but it's also just like there's this kind of like easy, like it's like a bit of doom. It's not really a bit of success. Like the working with React is like lovely. There's like all these like really cool error messages that really help you, and there's a good linters, and it just really like nudges you towards like producing something that actually works. This is so new; it doesn't have any of that. So I actually got quite stuck on a bunch of things. There's one thing actually that I did is where I would change like one word, like I turned like a synchronous generator into an asynchronous generator, and like my browser just went into an infinite loop on that tab, and I couldn't actually develop it anymore in that browser, because whenever I would like close the tab and open it again, it would still be like consuming that thread. Like I had to just open a different browser. It was very frustrating. It's like it's a small community. It has very high buzz factors. This one dude, but that said, it just like feels like React, and it, the good parts. I mean, like you have JSX, which is lovely, made me really instant productive, and only part that really kind of like changes how to do state management, and also with this asynchronous functions and to just fetch some data. I thought that was really really great. And it feels to me like also this is it's almost like it's just like I don't know, some philosophical statement. This library, it's like this is how it also could be done, and I really like that. Like I think React hooks was a mistake, and I think we should have had something more like Epitaph that came out like a week before React hooks was introduced or something, which actually also used generators. I always liked how React was like just JavaScript. It was always super simple, and now it feels like this is even more just JavaScript. So we're really using generators to deal with like state. And in the beginning I really sucked at generators, but now I feel like I've kind of like mastered this a little bit, and now I can actually start wielding this hammer called generators, and I'm kind of like, okay, what else? What's a nil? And like everything is a nil in the beginning, right? So like you're trying to hit everything with generators, and then it turns out it's actually not really useful most of the time. But sometimes actually generators are great patterns. And applying them outside like your component library probably is also a really good idea. So learning Crank will help you getting better at JavaScript, will make you more complete. And that is I find really interesting, because learning React in the beginning had the same effect on me, is that I learned more functional programming and those kind of things. So maybe, just maybe, generators is also a great fit for UI libraries. We'll have to see. But at least now you know a little bit, and I hope you enjoyed it. And if you have any questions, I guess we have live comments. You can like write them in the comments, and I guess like post there, yeah. So maybe David and Marco and whatever, you can come online again. So it gets a bit cozy in here. I guess you are online. Johan just has to push buttons. There you go.
Hello.
Hi. So if you have any question, just like put them in
So
Yeah. David?
how happy are you about Crank on a scale?
Yeah, I was actually really. I went through a roller coaster. I was like in the beginning, I was like, "Wow, this is cool," and then I really learned a lot in like the first day I was using it. Second day I came back, it's like I don't understand anything. Like it's like I don't get it at all. Then I had to learn generators again, and I got it. And then like day 3 was spent just like what the fuck. The what the fucks levels were so high, I just didn't get it anymore. And then we debugged my program, and then we found out like I was just making some weird ass mistake with generators. And from that moment on, it was pretty smooth sailing, and I really like thinking in terms of generators and just making the presentation. It really felt like a philosophically very interesting. Yeah. So how cranky are you since using Crank? Well, I'm very cranky today because I really fucked up in production today, and I was really not happy about it. So yeah, but it's nice to present.
How's the community for CrankJS? How far away is it to be a production ready?
Barely any, I think. I mean,
I mean, it's still a wonderful thing that a guy can put up such a complex tool out of nothing.
Yeah, totally. I mean, like it has a bunch of stars, right? I mean, like it's not nothing, but
it's definitely not nothing.
No, and I like there's okay, like it's not. Yeah, add logo. Important shit.
Yeah.
That's like 8 days ago. I mean, it's pretty relevant. People are saying it doesn't work in Deno. Well, then you're on top of your shit. If it doesn't work in Deno, no.
That's really bleeding edge.
Yeah. All right. Yeah. So yeah. Any other questions?
How likely is to fuck up with the generators? Let's say I want to bring it in with a team of juniors. What should I expect?
Well, the thing is, you already use generators, but it's like powering the stuff on the background. So like a lot of features are actually like, for example, async await. It's a syntax sugar account generator. So it's kind of like neato to be able to use that power. Like it's just like async await is just one use case, right? So like you can come up with other use cases that just make total sense. The thing is though, is that like it's really something you have to learn. Like it doesn't like work in the same way that you think, just like you have to learn like all the other things that the language offers. So there's a learning curve. But the thing, once you learn it, then you can take it anywhere, right? So that is the beauty, I think. It's like where are you going to take use effect? Like that's a completely useless skill outside React. Like it's like you want to, once you walk away from React, you're like, thank God I never have to think about use effecting or use ref or whatever the hell you learned.
So like you can say that you use reusable skills instead of non-reusable notions.
It uses like it uses constructs that are just part of the language for a really long time already that exhibit the properties that you need in order to do the things you need to do if you want to make a UI library. And I think that is like by itself just like really interesting. Like I also really like that it's just functions. Like when you think about a function, you always think like, okay, so we have a function. It just runs until it returns.
That's a nice SpookyTube. Read the comment. That's a nice one.
So what everyday task could this solve for me as a React developer? Well, like observables, I think that is actually like a more like overarching discussion. I think that will be coming in. I think CycleJS, right, is based on observables.
Yeah, let's not spoil it.
That's what. Oh, yeah, sorry. what does it solve for you? Like, okay, so like, having to deal with like asynchronicity, to deal with like state, generators allow you to abstract those things away really quite elegantly. And I think it deserves its own presentation. So I'm thinking maybe we should do like a presentation on generators and how it can be useful in your normal code, right? Like, so regardless of like what library you use, I think that's a good idea. Yeah. Generators for observables. I don't know anything about observables, so like I'll leave that to smarter people.
Yeah, it would be nice though to do the generator specific stuff. I've heard many people, and I can relate to them, that generators and regular expressions are more or less the same thing, made by aliens for aliens.
Really? No, regular expressions are like that's its own beast. But true, like in the same way that you with regular expressions, you're like every time you read it and you don't know it, you're like, oh god, Stack Overflow, and then you're just like, but like once you actually spend like a day on learning regular expressions, then you at least have like the beginnings to make use of that skill. And now I use it like sometimes. It's not like I'm continuously regexing everything, but it's still useful sometimes. Anyway, we should move on to the next one because otherwise it's going to be a very long night.
Yeah, let's go.
Right. All right,
everybody.
David.
Thank you, Arke.
Yep.
Thank you.
Bowing, getting a new beer.
Yay!
All right, David, will you share your screen?
Oh yeah, I have to push the button. You are not completely omnipotent.
I'm not allowed to do that. How about that?
Mm-hmm.
I'll turn off our other screens and let you have it. All right, David.
Hey. I'm brain farting. How do I make the terminal go away? This is not working. There we go. So, CycleJS. To frame this, when my father, who is a bit of a Gandalf character, quirky, intellectual, long white hair, long white beard, when he moved to a new village, he wanted to join the local theater troupe because that's what he does. But when he was going to do that, he found out that this theater group already contained an older guy with a white long hair in a ponytail, quirky and intellectual. So he ended up not joining because there's really only room for one such character, right? We have exactly the same situation here. So my father in this story is this upstart that you just heard about, Crank, and the already in place older village guy is CycleJS. It's eerily similar in the way that it all builds on the idea of so it shouldn't really be a framework as in a box with a gigantic API. We should just use an existing abstraction and use it really well. So just like Crank, CycleJS is more idea than API. The main difference is that instead of using asynchronous functions and generators as the abstraction, CycleJS uses observables or streams. And I mean, really uses them. It uses them throughout. So yeah, if I was person, I would have included some material on streams and observables here, just like Elke introduced generators. I failed. So if you are not in the know, an observable or a stream is sort of like a promise, but it can represent many values instead of just one. So an observable is like an asynchronous array that will emit events, maybe, eventually. And then it might end or not. You don't really know. If you are using observables, you have very likely seen this gist, which includes that dog. The introduction to reactive programming you've been missing. If you are like an RxJS or an Rx observables kind of guy, it's like a 90% chance you've seen that. And that's written by Andre Stolz, who is the mastermind behind CycleJS. So these slides and the code for the example I'm about to show you are available at this repo. I will put the link to that in the show notes, or Johan will, maybe in the comments. And yeah, we might start by looking at the example app, actually. So the design might look familiar. I stole this design by Mr. Elke B. And I'm also using the same API for COVID statistics. My app is slightly less nice to its users. So here you have to enter the actual country slug. Like United States is supposed to be like that. And here we get the stats. And if they are too scary, we can make them go away. Once we've loaded the country, we can reload it. When we've started typing stuff, we can clear the input. And you'll also notice this very nice button here. Now it's disabled because the input is empty. When I click it first, it switches to cancel or confirm mode. And there we go. It's like an "Are you sure?" button. So that's the example we'll be exploring. CycleJS, here's the logo. It's been around for a very long time. Here I have a link to a talk at ReactConf 2015, where Stolz presents Cycle. It's not the very first time he does it, but it's very early. This talk is really worth watching. It's a good talk, and also it's the talk where Andre will walk onto the stage, and this is a React conference, and he will explain to the audience, being React developers, how their framework is to be compared to a horse, while his framework, CycleJS, is a race car. He's temporarily forgetting that cycle has a connotation to different vehicle, but nevertheless, that's a really cool thing, I think. And since Elke got started, Cycle has 9,600 stars. So it's like 7-8 times better than Crank, because that's what that measures. So Cycle is totally based on streams or observables, which means you will need a library to represent streams. You're probably familiar with RxJS. That's one implementation of the idea. There is a proposal still, right, to have native observables in JavaScript. I'm not sure how far gone those are. CycleJS internally uses a stream library called Xstream. If you Google that, you will get to some XML utility tool. So don't click the wrong link. If you want to use Cycle with a different stream library, you can. There are adapters for like RxJS. The problem is that Xstream will still be bundled into your bundle, since that's a dependency of Cycle, although Xstream is a super tiny library. Stoltz used to be involved with RX, but ditched them when he felt their API was slightly too bloated. So the basic flow in a CycleJS app is this. We have our app, and the rectangles in my diagrams will be functions, and the non-rectangles are values. So we have our app, we feed it sources, and it will return sinks. Then we have drivers, which has the reverse signature. It will take sinks and return sources. And thus we have created a cycle, hence the name of the framework. All of this, all of the lower part, I should say here, is just pure functions. So app is just a pure function. It will take an object of sources and return an object of sinks. Drivers, on the other side hand, might do side effects. And drivers might be things like the DOM driver. That's the main thing, which will render onto the screen. In the little example you saw, we have some other homemade drivers. But before we dig into that, I want to talk about components, because that's what Cycle is all about. Like all cool frameworks, we have this notion that our app is just a pyramid of components. And every single component is a function again. It takes sources, which is an object containing streams mostly, and it returns another object also containing streams. So there's been other frameworks that have used streams. Angular is a famous example, although I think they've probably done more harm than good to the reactive programming world, since many people would choose to work with Angular, not expecting to have reactive programming shoved down their throats. Since RxJS is in Angular the main abstraction for outputs from components. Which people are not very happy with. So you really need to embrace the notion of using observables as your main abstraction, but of course that's not a problem in Cycle, because in Cycle everything is an observable. So before I show you some code, I want to show you this diagram, the model view intent pattern. So this is an idea on how to architect source code, which is older than Cycle, so you might have seen it before. And this is kind of complicated, but it sort of gets to everything. So I still want to just talk through it. So our component is a function that's fed sources. And part of that is the DOM source, which will help me catch events from the user. So I will feed this to my intent function. So this is part of my component. Part of my component logic, I move into a box called intent. And the job of the intent function is to catch user events and maybe other events and return a stream of actions, stuff that might happen in this component. This stream I feed into the model, which is another function within my component. And the job of the model is to convert the action stream into a state stream. This I will feed into the third part, namely the view, which will take the state stream and then return a stream of virtual nodes or vnodes, like you can think of them just as JSX elements. Under the hood, CycleJS uses snapDOM as the library for implementing this. And this stream of virtual nodes, I return to the sink, to the DOM, and then the DOM driver will catch this and render that onto the screen, and starting the cycle. So to show what this looks like in code, I want to start by showing you the code for this cute little button thingy. Remember this "Are you sure" button, which has 3 modes. So right now it's disabled because the parent is telling it to be disabled because this input field is empty. But then it can become non-disabled. And when I click this button, it will go into this "Are you sure" mode. Then I can cancel or confirm. And whatever I do, it will switch back to the previous mode. And if I click submit, of course, or confirm, it will emit a signal to the parent, which will catch it and try to make the request. So first cycle component. And I skipped past this in my presentation, but I have somewhere in here, I have an apology. Yeah, here it is. In the example app, there are a gazillion files because I just split stuff up minutely to be able to show it more easily. The typings are very verbose, and I have made the code even more verbose just to follow patterns to be more consistent. This is for the benefit of this talk. If I needed to, I could make the code more succinct. So, apology made. Here we have the confirm button component. As promised, it's a function. It takes sources and returns syncs. And in the body of the function, it first uses intent, as you would expect from the diagram. So to the intent, I feed the sources containing the DOM object, which it can use to catch events from the user. It returns a stream of actions. I feed that to the model function, which will return a stream of state, which I give to the view, which will return a stream of virtual nodes, which I give back through the sync to the DOM driver. For every component, I've made a dedicated type file where I will type out the sources and the syncs, and any other type that might be needed. For the sake of this button, it sort of has an internal state. It's just sort of like an enum value. It can be in 3 different modes, like we discussed. I've also made a type for the different actions that can happen within this component. It can be enabled or disabled from the outside, from the parent, and the user can do a maybe action when he or she clicks the submit button the first time, and it will switch to the waiting, are you sure mode. And then the user can also click cancel or confirm. Let's quickly look at these functions. So the intent function was first. It will be fed the entire source object. Sorry, do I want to go here first, probably? No, yeah. Yeah. Oh, here we are. I'm in the wrong components. That's why I'm confused. Sorry. Here we have the intent function. I get the DOM source, and here I can use the DOM source given to me by the DOM driver. And yeah, it's pretty self-explanatory. You can see how I find a certain DOM element. I will filter for an event type, which will give me a stream of those events, which I can then do whatever I want to with. And here I just map each of these different events to my magical enum action constants, which when giving to the model will return the correct mode. If I am suddenly disabled, I want to be in the disabled mode. If the user clicks the submit button, I want to go to the are you sure mode. And if anything else happens, I want to switch back to the waiting mode. And the view is not very dramatic. If we are in the are you sure mode, I want to render the 2 buttons, cancel and confirm. If I'm not, I want to render the maybe button, the submit button, which might be disabled depending on our current state. So it's a lot of code and it's a lot to grok, but hopefully you can see that everything is just streams. The only thing I'm doing when I'm creating a CycleJS component is I'm getting streams as input, and then I sort of just cross them and return other streams. And if you thought that was bad, it gets way worse. Because on top of this, there is an optional idea on how to handle state in the entire CycleJS app. The API is now called CycleState. So it's a sub-package of Cycle. It used to be called Cycle Onion, if you happen to stumble across older And the idea of that is, so our outermost component, the app component in our case, will own the entire state. It will be like the Redux store. And then as it renders child components, it will adapt this state for the children and give them what they expect, which is probably some sub part of this state. And then the child can update its state, which the parent will then catch this update and update the parent state instead. This has a rather interesting shape. So this is a component in such a setup. It's being fed a state stream from the parent, although adapted to the child. So it will be a stream of state objects looking like the child expects. And then the job of the child is to return a stream of reducers, not new state, but reducer functions that will be called with the old state and will then return the new state. So there are no actions in this world. If the user does something, that will emit a reducer tailor-made for that specific action. This pattern can be found in Redux land as well. I really like it there. So instead of having a central reducer in Redux, you can have a reducer in your action objects. It's not a super popular pattern though, so you might not have seen it before. But here it's the very basis of the idea. So when I am a parent and I'm rendering a child, I need to make a lens with a getter and a setter. So the getter, I will give a parent state object and it should convert that to the child state. And then the setter is for when the child will emit new state. I need to update the parent state in a way that makes sense. So I will create such a lens when I am a parent within this cycle state architecture and I'm rendering a child. And this is what the MVI pattern looks like when using cycle state. So I'm a component. I get the DOM source from which I will attach event listeners. And instead of emitting a stream of actions, I emit a stream of reducers. And I return this outwards. I feed the state stream to the view function as per normal and give that back. So there's sort of no model here in the model view intent. It's just intent and view, since the model is split across these different reducers. So I want to show you an example of what this looks like. Every single function except for the confirm button component follows this exact pattern. So let's go with the let's go with what? Let's go with the assignable input component. So that is this component here. I can type stuff. I can clear the input. And that's pretty much it. So it has no child state. Instead, this is just part of the form component. The assignable input expects to be given a state object containing field and placeholder. And the placeholder is really just configuration. I don't really expect that to change. But field is the content of the field. So this can be assigned from the outside. And then, of course, the child can emit an action saying that I want to update my contents. This is sort of like a controlled component in React. So here I have the idea of actions. These are the two different actions that can happen in this component. The user can type stuff, and then I can clear the field. But I don't want to emit action objects here. I want to emit a reducer. So when I want to create a type stuff action, I will give the creator here the new string. And then I return a function that takes old state and updates it accordingly, namely just by updating the field property. Same thing with a clear field. I return a function that will take the old state and just set the field to an empty string. And if go to the intent function. This is as you would expect. I catch events from the DOM, and then I call these action functions. You can think of these as action creators, except they will return a reducer instead of an action object. Same thing here. So in the component, I create this stream of reducer from the intent function, and I give my view function, which is very not uninteresting. I give that the state stream, which will give me a stream of virtual nodes, and then I give these back to the parent. So it's not a lot of code, but it's very concept heavy. So before you've wrapped your brain around this pattern, which tastes very differently from React, it can really be super confusing. If we look at code, and this will be the final thing I whack you with. If we look at the code for a component that uses a child component, like the form component, which uses the confirm button and this assignable input, I like to put the usage of children in a separate function. So you see, I have a function called use assignable input and use confirm button. I give both of them the entire sources object, and then I get their syncs, which I might do different stuff with. In the case of the confirm button, I want to use its submit stream. In the case of the assignable input, which is a proper state component, I need to include that stream of reducers back up to the parent. And to my intent function, I feed the sources object, but here I also feed in the submit stream because I need that to know when I want to tell my parent that, okay, the user has now submitted a new thing. Otherwise, this follows the same pattern. I have action creators that will actually return a reducer. The only thing that can happen in this component is the submit action. And I catch this in the intent function. The only special thing here is that I also need this stream of confirm button clicks to be able to do what I want. A final source code note is that CycleJS makes no distinction between a graphical component or just a function that somehow uses state or gives you something you want for your app. So the get country data function is not something that's visible on screen. This is the function that's responsible for making the requests to the API, handling errors and catching the data and making the initial requests. But it's constructed exactly like any other Cycle component. The only difference is that it doesn't need to have the DOM source or sync because it doesn't do anything with virtual nodes. But apart from that, it functions like a perfectly normal CycleJS component. There are a lot more things to say. You see, there are a gazillion files. I will leave that for you to discover on your own. My hope here was to give you a brief taste of what Cycle feels like. CycleJS is for you if you want to be edgy and make other people feel stupid. If you love reactive programming and have already embraced the idea of making streams or observables as the representation of everything. But it is a pretty solid thing. The API is very small. I've seen examples of people building large-scale applications with this, so it absolutely does scale. The caveat there is that you definitely need this state abstraction that we talked about last. If you don't do that, you need to do a lot of dancing when the child is dependent on the stream from your parents, but then the output from the child is a dependency of the thing you need to feed into the child. So you need to solve that circular dependency thing, which you can do, but there's a whole song and dance around that. And yeah, so the basic notion doesn't really scale. But if you embrace the cycle state architecture, then it's absolutely a way forward. You should know, if we zoom out for a bit, that even though the API has been very stable for a whole bunch of years, there are some semi-dramatic things happening behind the scenes right now. The next major iteration of Cycle will be called NeoCycle. And the idea there is partly to get rid of Extreme as an internal dependency. It will instead use callbags. I don't know if you've heard of that. That's an entirely different rabbit hole, although a really cool one. Callbags are a spec for making functions behave as streams. So you can do reactive programming as if you had a stream library like RxJS or Xstream, but you only use regular functions. You don't need a core library. It's really weird, but super powerful, and you feel so clever when you do it. Cycle will use that under the hood, which means the payload will be even smaller. Not that the size of the payload is a problem at all. And they will also change a bit of the architecture around drivers. There are some icky bits right now. If you have a child far down the pyramid that needs a certain source, then there's no dependency injection or context or anything like that. You have to thread that source all the way from the top. Then just as a side note, drivers are, you will be using the DOM driver, which is part of the Cycle package, and the state driver, but you can also make your own drivers. I've made a log driver here, which will log out the entire app state whenever something happens. It's kind of nice, and that's very easy to do. I've also made a local storage driver, so if I reload the entire page right now, you see I will still have the same state. So this is basically the argument behind Redux. Like if you put the entire state in one single place, that empowers you to do really cool things. And Cycle has exactly that as well. But yes, so there are some things happening behind the scenes. I'm not sure how imminent they are, but it's very ongoing right now. The CycleJS community, to answer the question before Marco has a time to ask it, is not super big, but it's not tiny, and it's very active. As you can imagine, this kind of framework attracts a certain kind of people. And there's been a yearly conference. I attended 2018. It's a super neat event. So it's like 40 people in the core community, not much more, I think, but they're all super active and diehard nerds. Precisely what you would imagine, pretty much. So yes, that is Cycle. This is the repo again. I will put the link somewhere reachable, as I said. And I think I'll stop there.
Cool. Let me add some. All right. So
Wow.
I guess questions.
I think so too now.
Would you want to use it yourself? I mean, like it does seem like it's not like it does seem to have a very steep learning curve. Like I had feeling I had to learn all the concept. Is it because you're just saying you're giving us your opinionated view of how to write CycleJS applications, or is this like literally how you're supposed to write CycleJS applications?
Good question. This is somewhat opinionated. It's a bit Davidified, to be honest. But again, the Cycle state architecture with taking the state stream as an input and returning a stream of reducers, that is widely adopted. It is.
All right.
But yeah, I think it's the same. Again, it's the same thing as with Crank. It's a steep learning curve, but the learning curve is not reactive programming.
Mm.
It's a skill you can use elsewhere, as Marco alluded to. So the cost is high, but the cost is like paying that cost has benefits far outside of Cycle. You will become a better handler of observables.
Yeah, so the payoff
Just like
is
you would probably master generators.
broad and long term rather than like narrow and immediate.
Yeah. Also, when you try it, it's sort of, I mean, it sort of works. Everything is a stream. It's very nice. I can show you this. This is really just a proof of concept. They haven't done any work on this in years, but this is the CycleJS dev tools. Since everything is a stream, you can draw a graph of your entire app. So this is my entire app. And as I do stuff, the idea was that you can see the events walk through the app. It's not really practically useful, which is why they stopped developing it, I think. Yeah, it's just the notion that everything is a stream is powerful. But exactly like you described, Elke, I just inputting this example together, I was several times I was really hampered by my poor just streaming skills. I would do stupid mistakes, and since I don't like, if you wake me up at 3 o'clock at night, I couldn't tell you if you're supposed to use merge map or concat map or switch map for this particular use case. And before you have put that kind of knowledge into your cerebral cortex, this framework will trip you up. Absolutely.
Yeah.
But it's so cool.
Exactly. So cool. Like you put it on your resume, though. Like that's like the only measurement of success. You talk about GitHub stars. That's only for the author. That's his resume.
Yes.
Very cool. So would you use it? Like would you, or it's like to do anything, you rather just have something simpler or something you know better?
No, but I would use it. I mean, I do feel like I want to get better at observables. That's a skill that's useful in my day-to-day, since we use RX observables to handle the Redux logic and side effects. And many times I will trip up there. Also, and I should have mentioned this earlier, CycleJS has good interoperability with React if you would want to. You can wrap a Cycle app just like you would a web component and use it as an atom in a React app. And you can do it the other way around as well. So there are adapters that give you the ability to take a React app and use that as a leaf in the CycleJS app. And you would just feed it a stream of props. So I could use like a React UI library or whatnot. I probably wouldn't, but I could. And yes, I absolutely would want to try to build something bigger using just Cycle.
Cool.
But I'm very tempted to try Crank, though. Damn it.
It's all places. Next year. Next Corona wave, you can do that one. All right, so we go to the next one?
Sure.
Or maybe any more questions from the viewers?
Yeah, are there?
Only smart remarks.
I think I scared them all off.
Is your brother in there?
Yes.
All right, cool. Thanks.
All right. Thank you.
Yay.
My beer's empty. I'm going to fetch a beer.
Yeah, I
But maybe we
will.
should just continue rolling, right?
I'm gonna go like this.
Yeah, now Johan is going to win the GitHub Stars race, I think.
No,
We'll see.
I'm going to do the query presentation last.
We'll see. Do like this. Talk to you guys later. Contrary to my fellow presenters, I do not wish to see myself, so I guess you didn't hear me. All right, let's see if we can do this. Well, let me start this presentation by introducing myself. My name is Johan Jönsson. I am 32 years old and I'm the lead game developer at Relax Gaming. I have about 10 years of professional experience within the field of software development. The industries that I've developed software for include the airline, betting, educational, and gambling industries. I'm also part of the Malmö JS crew, and as such, I'm one of the organizers behind today's event. Disclaimer: I am not in any way associated with the Svelte team or getting paid by Svelte or any of its representatives to do this presentation. I am simply a fanboy who would like to share my take on what I think is an exciting new piece of technology. With that out of the way, let's begin the presentation. So, this presentation will act as an introduction to Svelte. I will be presenting the reasons here why I think it might be an interesting substitute and perhaps even a potential successor to React. First off, we should start with describing what it actually is. Svelte is simply a tool for building fast web applications. It is in many ways similar to JavaScript frameworks such as React and Vue.js, which share the same goal of making it easy to build slick interactive user interfaces. But there are some crucial differences that we will get to. Svelte, to me, represents something utterly new and an idea that will change the way we think of JavaScript irreversibly. To me, it represents a completely new paradigm in how we create and run JavaScripts that power the front end of our web applications. But it's by no means the first paradigm shift to occur in our field, and I would go so long as to say that it represents the third major shift when it comes to using JavaScript to power the front end of web development. What I mean with that and what came before it? Well, it's history time, folks. Yay! In all seriousness, though, I think it's going to be easier if we start at the beginning so we can all get some context to what I mean with Svelte representing the third paradigm shift. I'm aware that a lot of you out there will already know this, but please bear with me because we're not all on the same level. If you're watching this later and feel confident that you already know how we got here, please feel free to skip this part. In the beginning, JavaScript was invented to offload the most minute tasks to the browser and provide simple feedback. It was extremely limited, but people started to take advantage of the benefits that it offered, although it was very hard. Since it was so hard to achieve anything at all, and there were large discrepancies between the different implementations of JavaScript in the browser, someone came up with a brilliant idea. What if I created a framework that will simplify the handling of JavaScript? This was a brilliant idea, and it led to the creation of jQuery, along with launching a completely new paradigm and the first major JavaScript paradigm shift in how we use it to create web pages. Suddenly, it was moderately simple to do genuinely advanced application in the browser. But there's always a but. It was still relying on manipulating the DOM directly. This made it more suited to sprinkle on top of server-side render pages rather than to use it to render a page completely on the client. It could be done, and it certainly was, but it was really a good idea, since you would end up needing to write your own templating system along with handling data binding, and on top of that, needing to handle the added complexity of having to deal with user inputs, etc. So while it could be done, the idea to do so was rarely any good. Or rather, the idea itself was good, but the framework actually didn't really support it, leading us to the second paradigm shift and the third and current era of JavaScript. Do you guys hear me? Elke, do you hear me?
Yeah, I hear you. You're waiting for like audience and everything when everybody's muted?
Yeah, I know, but someone could. I thought someone would write. All right. Cool.
Just continue.
I will. So the idea itself was good, but the framework actually didn't really support it, leading us to the second paradigm shift and the third current era of JavaScript. It all started with Knockout and Angular. The sole purpose of these frameworks were to move the rendering from the server to the client, making it easier to create even richer and more advanced web applications that would run solely in the browser. React and Vue came later and are both currently mostly regarded as industry standard. Finally, we're right. We can now start building real applications. So what's the issue, you might think? It seems like we've reached the end of the tunnel. We can now easily create rich client-side render applications rivaling many dedicated desktop apps in its richness and complexity. Well, I would have to agree. That is certainly true. But normally, you install your renderer and libraries for making your neat little application, and then include most of these as dependencies that will run alongside your actual business logic. And yeah, these can take up quite a lot of space, many times outweighing your actual code multiple times over. Downloading and adding functionality that many times ends up never being used, and instead is just taking up unnecessary bandwidth and memory. So what Svelte does, and why I think it represents such a huge step, is that it's actually not a library with all the potential issues that might come with that. Instead, it's simply, in one word, and here's the revolutionary part, a compiler. The Svelte syntax is based on JavaScript, but it actually adds some key functionality on top of normal JavaScript, which makes it not only a compiler, but its own language. And you might be thinking, well, so what? I've been using a transpiler for years. That's nothing new. Who cares? Well, in my opinion, you really should. The transpiler is exactly that, a transpiler. It might let you write your JavaScript in another flavor than that of the browser, but in the end, your result will not only contain the logic necessary to execute the code you have written, it will contain all the logic that your library of choice has to offer, regardless if you use all part of it or not. So you should really care. This brings us to the conclusion of the description/history part of this presentation. I would like to end this part by declaring that the third major paradigm shift in how we create and use JavaScript to power our web application has started. But Svelte is not alone in using this approach, though. Stencil.js, which is a toolchain for building reusable, scalable design systems, is also being built using the same principles. I am convinced that we'll see more and more of these compiler-type frameworks popping up. However, Svelte is here now, and out of our two existing alternatives, it is certainly the most mature of them. I'm not sure it will be the golden standards for years to come, but just like jQuery and Knockout brought about the paradigm shift, it is my firm belief that Svelte will do the same. Well, this presentation is not only about Svelte, it's also about how Svelte relates to React. I will be going through a couple of key differences in how Svelte compares to React in both terms of usage and functionality. Before, we talked about how fast Svelte is, but coming from React line, you might be thinking, how can it be fast when it doesn't rely on the virtual DOM? We've all heard it. React is fast because it used the virtual DOM to calculate its diff before applying them to the real DOM, make it so that no unnecessary changes are propagated to the slow real DOM. And sure, the virtual DOM is fast, and it makes React infinitely faster than if we were to render out all DOM changes directly instead of doing the diff checks in memory on the virtual DOM beforehand. But that doesn't actually take away from the fact that the virtual DOM undeniably adds an additional extra step that will act as an overhead to our applications. So how does it work? How can Svelte be faster than React? And I think David will know this because it is faster. It's a lot faster. It achieves this by figuring out what variables are used and where, which variables it then needs to turn into observables. So here we have observables again. It does this pre-calculation behind the scenes at compile time, making it seamless to the programmer, taking away all the necessary boilerplating and plumbing, making it just work. On top of supporting all the expected functionality that other modern client-side rendering frameworks do, Svelte boasts additional support for styling. Using a style tag in your component will make its scope to be used only there. You will hence not need to think about how it might affect the styling of your other application elsewhere. Motion. Svelte has built-in support for using tweens or spring motion, making it easier to implement. Transitions. Everyone who has used React knows how horrible it can be to do a smooth transition when having to coordinate the CSS fade and the removal of your component. There is built-in support for that using Svelte. Animations. Internal support to implement smooth animations to adjacent elements when moving elements around. All these examples require extra handling or libraries to get to work nicely with React, and will work out of the box using Svelte, all while taking up no extra bandwidth or space if your application doesn't require it. Another area where Svelte excels is when it comes to the required size of your code base to create desired functionality. The following comparison shows how two fundamentally identical applications will be written using React versus Svelte. These two examples were taken from the official Svelte page and is used here to demonstrate the radical difference it could have on your code base. Here we have a simple code snippet written using modern React and the useState hook. It's by no means anything fancy. It's just a simple application with a state that controls the two values, and then does a summation of those values in the end, complete with all the logic necessary to update those values using simple input fields. It's very simple, it's very nice, it's very clean. All in all, this solution clocks in at 442 characters. Here's the equivalent code written using Svelte. So one thing one immediately would notice is that in Svelte, you write your code from the standpoint of plain HTML, just like you do in Vue, instead of writing it in the more traditional JavaScript-centric approach, or in React JSX case, which is more like a boo bag of intermixed HTML into the JavaScript. Another thing that stands out is the internal state that is being used. In React, we have to declare our variables in the state that will be used to update the renderer. As previously mentioned, we don't need to do so in Svelte. It will simply look at the two variables and automatically apply the observables pattern onto them, if needed. Here is a concrete example where it just works. No boilerplate or plumbing required. Another nice thing in this example is the bind prefix used in these inputs. This lets Svelte know that it should update the values automatically when the inputs are being used. I know it's a pretty narrow example, but it speaks volumes nonetheless. The React code was 442 characters. The Svelte equivalent clocks in at 145 characters. This means that the React version is more than 3 times as large as the same code written using Svelte. Looking at these two examples, which one do you think is the easier one to read? I at least think that this code is far less boilerplate and hence easier to read and understand. So, wrapping up this presentation, I think that you should care about Svelte because it has no overhead. Since Svelte is a compiler and not a framework, it doesn't actually add Svelte to your list of dependencies that your user will have to download. Instead, it interprets your input at compile time and then tries to create a single output as optimized as it can be. Since there is no overhead, you could easily start creating and swapping out modules in your application at no additional extra cost, making it suitable to easily do a soft transition. The zero overhead also leads to faster execution compared to most client-side rendering libraries and frameworks due to the code being interpreted and computed at compile time instead of runtime in the browser, saving precious computation and bringing down and compressing the overall footprint to a minimal of what it actually needs to be. Third, it has true reactivity. React is in many ways not truly reactive. It constantly re-renders everything into its own virtual DOM and then does a diff check to see if it needs to do an actual re-render. Since Svelte looks at your code to determine internally if it needs to use observables or not, it doesn't need to rely on this to figure out what to re-render it. And the reactivity will hence come pre-compiled out of the box. Fourth reason you should care is that it has advanced built-in support for things like styling, transition, animations, and motion, something that most other UI frameworks struggles with to handle gracefully. It is also easier to learn, since Svelte is built to comply with the normal HTML and JS standards instead of its own JSX. The Svelte.dev site is also a good source for comprehensive documentation, as well as rich tutorials, which will get you up and running in no time. Finally, I think it's the future. it's of course a little subjective, but I do think that the principles behind Svelte is the most exciting development we've seen in our field of work for years, and I'm confident that it will usher in a new era of JavaScript development. So again, for anybody remotely interested, if you haven't already, I would highly recommend you going to through the Svelte tutorials at svelte.dev. They're really comprehensive and will get you up and running using Svelte in a very short amount of time. All right, Q&A. Let's see if I can open you guys up. Hi.
Big words.
It felt like my father was reading a bedtime story.
I'm sorry.
No, that's good. You even have pretty pictures. Really nice.
Did you have the Bible of Svelte?
The Bible?
The book that you read us.
Yeah, it's a nice book.
It's a good way to do it, actually. But what about that? That's actually a question to the three of you. What's about module splitting? Like, are those frameworks supporting the possibility to split bundle splitting, no module splitting? So to optimize your code base in order to produce small bundles that you load as needed.
I think that is like kind of like orthogonal. So the the bundle splitting, I think in most of these frameworks should be like something like it would really. I don't know if it's Svelte, but it sounds to me that like the okay, maybe it's not orthogonal, but it should be, like because in React, you want to create bundle splitting. A nice way to do that is with React. It's lazy, right? So you can do like this dynamic imports. I don't know how to do it in the other frameworks, but in theory, it's just like JavaScript. It happens on like the on the kind of like on the Webpack bundling layer. So, good question. I don't know about like when you compile it.
Yeah, that was mostly for the Svelte part, actually, because it doesn't rely on a library, on a shared library, right? So if every part of it is compiled, I wonder. I mean, I really like Svelte as an option. I tried out. I got in love with it, but I still not sure. I do understand what are the implications for large code bases. That's kind of the thing that I keep asking myself. Of course, if we take a small example, it's going to win many times on bundle size, on source code size, and it feels way more intuitive. It looks to me like a kind of Angular done right. With big stuff. But I question a big code base. How does that look like?
I mean, I'm pretty sure that you could split it up. I mean, it supports all bundler like rollup and the Webpack, so there shouldn't be any issues splitting a big project up into different bundles. Actually, I think it should do better than most other, because it would be easier to split it up. Since every module is self-contained, so to speak, is pre-compiled, then it's just a matter of downloading it and executing it, so to speak.
Like what? I guess like maybe you can explain it again. Maybe you like I just didn't get it. But like, if you have just a lot of updates coming in, like to your lot of like data or whatever, like how does Svelte make sure that it doesn't do expensive DOM manipulations? Like how does it make sure it doesn't like update the DOM unnecessarily, reducing performance?
Now, I mean, it has observables. It uses the observables pattern directly onto the variables, so to speak.
Okay, but then you mean like that's kind of like throttled, or so like it doesn't update every time it updates at a particular pace that it finds that it's performing or something. Like how does that happen?
It uses TensorFlow under the hood to apply machine learning to figure out how to update the
Mine some bitcoins and then
on the side. That's with using service workers. No, the other ones.
Now, I'm not sure if I understand your question completely.
I mean, observables is not a solution to like, I think I'm not entirely sure, but is maybe David knows, but is observables like a way to solve the problem of kind of like updating the DOM too often or in non-efficient manner? Essentially, that's what virtual DOM does, right? Like it calculates the minimum stuff it should do to the DOM at a rate that like is hopefully as usable as possible, without, and so like you tries to, it's an abstraction in the middle. So like also observables abstraction in the middle, but what does it do? Like, does it also have like if I would think that observables is just like, okay, so you deliver all this data to in a way like it's a stream of like data into like this rendering engine, and then the rendering engine can decide to implement a virtual DOM.
I don't think it's like with the virtual DOM, but with like you subscribe to a stream, so you can actually filter out values until you find a diff. And when you find a diff, you propagate it down. So probably the observables that Svelte applies, they shield the DOM updates until the new value comes in.
But that's the thing, right? If there's new values the whole time,
knockout style, so to speak.
if there's new values the whole time, then it would clog the. That's kind of the beauty with the virtual DOMs. Like you can just ram updates. Like you don't have to care, because like the virtual DOM will make sure that it will not try to update the DOM if it's not done updating the DOM the previous time. Like it will not. The abstraction throttles for you. So obviously, like observables also throttles for you. I'm just like wondering, like.
I'm not sure it needs to throttle that much compared to the virtual DOM. I mean, what React does is you have your props, and then you render it out to see if they have changes. And if they have changed, then you will propagate that change near to your subcomponents, right? That's what we're talking about. So you do need to do that re-render to be able to propagate it to the subcomponents. And that's you don't do with observables. Instead, you just hook into the stream and re-render the values which are actually listening to it, so to speak. You don't need to re-render the whole UI to just change a simple little number. You can just find that number and change that in the DOM, so to speak.
Okay, but like didn't like Angular 1 or whatever it was called, I never used it, but didn't that thing like completely break down on performance because of this like having like this two-way binding? Maybe they didn't use. I have like no idea, but I'm just like it sounds like what Angular 1 did, right? So, but like
that's why Svelte is Angular done right. They did it right this time.
They precompile it, so instead of having to do that abstraction in runtime, you can precompile it and do it, in compile time, so to speak.
Yeah. So
how is the DOM updating done to prevent too many instructions to the renderer? I guess we have. I mean, if we want to answer that, we have to look into the produce code, and there has to be some kind of cached value. So like if I keep sending the same value, I either comparison by value, comparison by reference on objects, more or less like the mechanism of virtual DOM. Probably it's just missing the layer of the virtual DOM. It does directly on a cache applied to the subscriber that is then applied to the DOM element. I'm just guessing. I have no idea.
Yeah, I mean, it's using the observable. So if the observable haven't changed, then it's not going to render it out.
So maybe the observable does this cache layer. I mean, if there is a constant stream of the same value being emitted, then you have to stop the renders at one point, right?
Yeah.
Maybe we can. Maybe David can like give his input, and then we can go to the question from Maris about type safety.
Yep.
Yeah, as a final note on exactly this discussion, the old truth that the DOM is super slow is less and less true as time goes by. So, I mean, SnapDOM, the library that CycleJS is using, and which is also very popular on its own, and it's been being used in other places, relies on the actual DOM. So there's no virtual abstraction layer to do the diffing. And if you don't have that, of course, you have less overhead. The idea behind the virtual DOM was, of course, to do heavy lifting that you don't want to do in DOM space, because that used to make a whole lot of sense. I think it makes less and less sense as time goes by. Amen.
Amen. Type safety. Maris, I hope you're still listening. It was like 7 minutes ago you asked the question. It is a pretty like dense question. I mean, like short. So I guess you can make whatever you want out of this, Johan.
Like type safety. Yeah. I mean, it doesn't boast full support for TypeScript, which I guess the question is referring to. But I think they're working on it.
But that should be like TypeScript compiles to JavaScript. And if you just make sure it compiles to, I guess that's non-trivial, otherwise they would have already done. I'm trying to newbie my way into this. Probably shouldn't. Interesting comment from SpoikitTube. Inner HTML is fast now in comparison to years ago. And you say truth, David. Amen, brother. Amen. Why that? Like, enlighten us.
The question is, how fast is it?
David. Can I reuse static checking tools like TS, ESLint, etc. with it? I guess.
Yeah, you can. And it has its own integration. So if you use like if you use like Visual Studio code as an IDE, you can download support for highlighting it and so forth.
So have you used it in your work?
I have not.
So do you think like the DX will be like, they say like, oh, if it's like the more you compile, the harder it will be to understand whatever you code you have to work with. And that is kind of interesting because in React, of course, like you're looking at the component and you're seeing it just like you wrote it, and you don't understand what the fuck's going on. Like just like you have some sort of skill closure shit going on, and then somebody, you should use a ref. You should use like overreacted.io so that you become a master in this arbitrary hooks API. And then you do all that, and then you come back a month later to your code, and you're like, it is exactly the code I see in my editor, and it's the same code I see in my browser. So like, it is just React. I don't fucking understand what I'm doing here. Like, what is this? Like, anyway, so this argument of like that you're seeing your code as if it's like what you write is what ends up in the browser is like an important argument. But if what you're writing was poop to begin with, then it will still be poop when you see it in the browser. Anyway, rant. Sorry, tangent. I will get back
SBS.
to my question. Sorry, I was answering my own question. Or answering somebody else's question. I don't know what we're talking about. But anyway, what I noticed is with React is that you at one point you're like, okay, so you get this error, and then like you're going to stack trace, and you're like, fiber node, fiber blah blah blah, fiber this, fiber that, and you're just like gone. Like it's like you have no clue. It's out of your control. It is in complicated algorithmic effects land. And is that the same with Svelte, or is like Svelte like, did you notice that, like, okay, so I try to do a simple thing and then it's just like, it is the code, my own code is like simple, my component is there, I get thrown error and like I'm immediately in complicated land, like I don't get it anymore? Or does it stay simple? Is the stack actually pretty short, because like the next thing you see is like it actually does an imperative call to the DOM and just updates it? Like how short is the abstraction?
I would say that it's even shorter than for normal React, so to speak.
Without fiber.
Without fiber, so to speak.
Yeah, because you don't have the virtual DOM. So what it does essentially, it compiles the stuff that you write. It compiles it to really optimize jQuery code, right?
Yes.
No, it's not kidding. Like that's what it does. Like it writes. It's a TensorFlow jQuery. Like if you start looking in the no, but like what I mean is that like it actually knows much better than you how to properly imperatively interact with the DOM. Just like the virtual DOM knows much better than you how to imperatively act with the DOM, because the DOM is finicky, right? It's hard to do right. So that essentially what it does for you. But then instead of that, you go through this huge abstraction funnel. You actually have this like small little like needles that you pinpoint into the DOM, and then the DOM, and that's like how kind of like it's like little mosquito bites into DOM.
Okay. What was that beer that you were drinking?
This is
Are you sure?
It's one of these special what do you call it? Edibles. They come from California. Wrong stuff.
All right, I think we have dropped a lot of viewers now.
Yeah, it's just the four of us.
So maybe we should end this.
So that
It was
we
very
can
nice.
into the night.
Yeah, I can keep going.
I think it's been a very, very decent Malmo.js. I mean,
we should never do it in real life. We should always do it online.
Come on. In real life, there is pizza. I love that part.
That's true.
True.
And more beer.
A free beer.
That's true.
Yeah, when you have to buy
a
your
human
own
contact
presentation.
That's what I like. You can hug people.
Yeah.
Here comes the question. So we did that online in the only country in Europe where we didn't have to do that online.
True.
You're Italian.
Fair.
It's not safe.
Okay, exception raised.
So, okay, here's a question. If racism is like discriminating against race, what is like discriminating against nationalities? Is that nationalism?
I'm going to
Wait, All right.
Yeah, we have Mary's coming up with a very nice suggestion.
All right, cool.
Delivered pizza, please.
So
we're gonna have to be better when it comes to that.
On YouTube,
Yeah,
right?
yeah.
Video one. Video will be available on YouTube.
Huh?
This video.
Yeah. We can make this available later.
I think it went really well, but I like next time. Maybe what we can do is we can have like more people in here, so it's more. It feels like the community is also here. We can try to, because with most people, I think we're on this. Like we trusted them. Like it would be nice that people can ask questions.
I think when we started, when we chose to do this, Google hadn't launched their new meeting platform. They were about to do it when we planned this, and I think they have actually launched it now. So we could try that next time.
Even better.
Yeah, and then we could have live comments. So it's what it was, but I think it worked pretty good. in the end, anyway.
Yeah, it worked awesome. Like I think it's a great tool. This.
All right.
Thanks
Let's
for
end it.
organizing, Johan. Awesome.
Well
Relax
done, Johan.
Gaming. At it again. Everybody, if you need a job,
Yay.
Yeah, we're looking for people. So
yeah, this and Relax Gaming. Are you still looking for developers, Johan?
we are.
Yeah, good.
Yep.
All right. Cool.
Okay,
All
guys. Next time I'm thinking to show a little bit of coding in the browser, like starting from as simple as a CodePen.io and ending up in how to build your entire cloud-based IDE with Visual Studio running in an EC2 machine served through a browser with automatic DNS setup, all the stuff entirely for free, of course. What do you think?
Sounds cool.
Sounds good.
Let's
Will
try
you do
that.
it before the summer holiday, you think?
Half June, something like this.
Yeah, it's pretty soon, huh? It's like in 2 weeks.
Second half June.
End of June. Let's do it. Try to do it maybe before midsummer.
Yeah. Do you have plans for holidays? Are you traveling around?
We were supposed to be in Italy.
Good luck with that.
Yeah, not doing that.
Yeah, that's quite tough now.
Yeah.
Well, thank you,
All right.
everybody.
Thank
See
you.
ya.
See ya.
Bye-bye.
Bye.
Bye.